Welcome back as we continue our review for our quiz for next Tuesday. So now we'll be looking at number 13. We are looking at an exponential function, which is f of x equals 2 times 3 to the x. Sorry about that. So we'll be looking at the exponential function, f of x equals 2 times 3 to the x. First, we'll be evaluating for x equals -2, -1, 0, 1, and 2. So I'm going to make a table for that. My x's are -2, -1, 0, 1, and 2. This is where I'll be plugging them in. So it'll be 2 times 3 to the -2, 2 times 3 to the -1st, 2 times 3 to the 0, 2 times 3 to the 1st, and 2 times 3 to the 2nd. Now I'm going to write my answers over here, and then I'll write my ordered pairs up top. So to do the work, you'll be probably doing this on Desmos, but I'm using a regular calculator. So 2 times 3 to the -2nd equals a very small decimal of 0.222. Repeating. So my ordered pair would be, and I'm just going to write these up top here, -2, comma, 0.2 repeating. Now I'm just going to go back to here and evaluate this for -1. Now I'm at 0.6 repeating. So when I plug in -1 to that function, I get 0.6 repeating. When I plug in 0 to that function, I end up with 2. When I plug 1 into that function, I end up with 6. And when I plug 2 into that function, I end up with 18. So now I have all my ordered pairs that I need to graph. I apologize for the bell. To show that you evaluated for it, you can use this table, and you could have filled it in like this. There's your 0.6. There would have been 2, 6, 18. You can write them as ordered pairs, or you could have wrote them in functional notation, such as f of -2 equaled 0.2, repeating. Any of those would have been acceptable. I'm just looking to make sure you evaluated correctly, so that way we can now plot our points. So part B says, graph the 5 points and connect with a smooth curve and arrows. So I'm going to start graphing these 5 points. Remember, all ordered pairs go in XY form. So I start with -2, and I move up just a tiny little bit to get to 0.2. The next one was -1.6. So now I go to x is -1, and I go up a little more than halfway to 1 to show 0.6. So hopefully you can see these points showing up on the video. Now I'm at 0, 2. So that means I don't move at all on the x-axis, and I move up to where y is 2. My next point is 1, 6. I go to x is 1, y is 6. Plot that point. My final point is 2, 18. Now I want to connect these with a smooth curve. So this I will give you a little bit of leniency on, but you need to try and draw as smooth as you can with arrows. So my graph will look something like this. Be sure to show that you keep going on and get close to 0, but you never touch. If you cross past that x-axis, it'll be marked wrong. And then you have an arrow going this way. So we have all of our points labeled, and now we have our smooth curve with arrows. And it should be kind of obvious that the graph keeps going up and to the right, and it keeps getting closer and closer to 0 to the left. Now we have to identify the domain and range. If you remember us doing the domain and range from the very beginning, this is going to be exactly like that when you look at the graph. Here, I drew the graphs, or you went on Desmos and graphed them and looked at it. So now the domain, just like all of the other exponential functions, the domain of this graph exists as far to the left and as far to the right as you can imagine on this graph. So the domain is all real numbers. The range, well, this graph only exists above y equals 0. Here's y equals 0, and you can see that this graph only exists above it. So this graph exists in the region where y is greater than 0. Remember, domain deals with x's, range deals with y's. Now, this one should be straightforward from here on out, especially after all of your choice board review. The population of rabbits on a large island doubles every year. On January 1st, the population is 150 rabbits. Which equation can be used to find the number of rabbits, to find the number of years x it will take for the population to reach 4,800? So we know we want to end up with 4,800. All of these start with that. So we have to write our original equation. If I was going to write it, it would start with y equals a times b to the x. This is our general form of all exponential functions. Y equals a is always my initial value. Well, going back to the problem, it said the original population was 150. So I started with 150 rabbits, and then I have to go back, and you have to be a little bit careful here to read. It said it doubled every year. Well, doubling means times 2. So I started with 150 rabbits, and I multiplied by 2 over and over again. Or in other words, y equals 150 times 2 to the x. Remember, a is your initial value, b is your multiplier. So I look up here. If I want to end up with 4,800, y would be replaced by 4,800. So D is our correct answer. 4,800 would equal a starting amount of 150 times 2, or doubled over and over and over again. That concludes this portion, and then we'll have one more clip going over compound interest.